Hello, welcome to this short presentation on data reliability and validity. I'm Dr. Maloney from Franciscan University of Steubenville, and in this presentation we'll go through the difference between data reliability and data validity, the general concepts, and then I'll get into more specifics about what do these concepts apply directly to our business analysis class, especially in terms of your review of the data reliability and validity of the data sets you will be analyzing for your presentations. First, a little bit of data reliability. So it's defined as the degree to which an assessment tool produces stable and consistent results. So that's a kind of a long way of saying that the idea is that the assessment tool you use, the survey, the observations, the experiments you use, should produce the same result each time you do the test. So for example, a simple example that you can all relate to is a scale that you have at your house. It should measure the weight the same each day. So if I've done the scale today and tomorrow I should have the same weight. Maybe a little bit heavier or less depending on how I ate that day, but pretty much the scale is a reliable measure of my weight and it stays the same each day. There's two types of data reliability that I wanted to touch on briefly. There's lots more than these two, but these two lead into how we need to think about these things for our purposes for this course. First, inter-rater reliability. So do different raters rate the same observation the same way? So if you and I both view a presentation and we both use the same rubric to evaluate those presentations, do we both rate the presentation the same way or not? So is the tool reliable in the sense that two different people or two different raters could rate the experience the same way using that tool? So that's inter-rater reliability, which is really important for survey data, for observation data as well, to make sure that two people can evaluate the same experience the same way. Second is test reliability. And so if you repeat the same experiment with the same tests, you get the same results. So if we go through and survey students at Franciscan about their expectations of technology on campus, and we use this survey and we do the same experiment 5 times with different groups of students, do we get the same results each time? So we're testing whether or not the test itself, the survey, the instrument, is a reliable test. So those two things are critical because as we look at some of the data that we'll be using in this course, you'll see that they do these surveys each year. They do these data collections each year or every quarter or every 10 years. And so are these two things accurate? So is there inter-rater reliability and is the tests reliable each time they do that test? Second, data validity is different than data reliability because it measures how well a test measures what it's supposed to measure. Okay, so for example, with the scale again, this asks the question, does the scale actually measure the correct weight during the test? So reliability asks, does the scale measure the same weight each day? But if the scale is off by 5 pounds or 10 pounds, it's going to measure the same weight each day, but it's not the correct weight. Okay, so if this asks the question about the test itself, does it measure what it's supposed to measure accurately, not does it measure the same weight each time? So I always think about it like a shooting practice, right? So if I'm shooting archery and I shoot in the same spot each time, then my sights are reliable. But if I'm not hitting the target, if I'm not hitting the bullseye each time, then my shooting's not valid, right? In the sense, accuracy versus consistency, right? So that's a simple example of the difference between validity and reliability. So there's two different kinds of validity that I wanted to touch on as well. So first, internal validity. So are the findings the result of intended variables or other factors? And so if you think about that question in terms of data validity, so if you have some sort of experiment that you do, can you say that what you find in that experiment is a result of something you're actually trying to measure or not? Okay, so if I give you a final exam at the end of this course and you score 100% in that exam, can we say that your scoring 100% in that exam was a direct result of the course, or did you have a preconceived or pre-learning that you had before you got to the final exam, before you got to my course, right? So the question is, does that final exam prove you learned something in my course, or prove that you learned something somewhere along the way in your life, right? So you can add other things into the test to make sure there is internal validity. So if I'm trying to measure your achievement in my course, in your learning in my course, I would have to give you a pre-test to see what you knew before the course, and give you a post-test, a final exam that would measure what you learned after the course. Then I could say, okay, here's what you knew before, here's what you knew after, so does my course help you to learn or not from what you started from? Right, so that's the idea of intended variables. This also brings up the question about causation versus correlation, which I'm sure you may be familiar with, but just to reiterate that, and how you speak about your findings, it's critical that you identify whether the finding is a cause of a variable or if it's just a correlation to a variable. So in the test example, can I say in the final exam without a pretest that you passed the final exam because you took my course? That would be a causation, and I couldn't say that um, unless I have had you take a pretest, right? So I couldn't say for sure that my course was the result of you, or your A on the exam was a result of you taking my course, right? That'd be the causation. But if I don't, I might be able to say there's a correlation between taking my course and doing well on the final exam, right? So there's lots of different examples of that that we'll come across as we talk more about that. But there's the idea that you shouldn't assume that there's causation in correlated values, right? So be very careful on how you speak of these things, and also what your assumptions are and what your interpretation are of these data, because causation is not the default. So the correlation may be present, that doesn't mean there's causation. External validity, on the other hand, is how applicable are these findings to the real world. So whether it's caused or correlated, how much can you apply these findings to the real world? So a lot of times in experiments and studies, you want to try to reduce the variables that could affect um, the findings. And so if I'm trying to study student success in my course, I'll try to control things that they learn outside of my course. I'll try to control their interaction with each other. I'll try to control other things that could affect their learning other than just coming to my class, right? So there's lots of variables that could affect your learning. Even if I did have a pre-test and post-test, there's nothing to say that you couldn't have learned about the course material somewhere else other than my course, right? So how can I really know for sure that what you learned in my course is why you did well in the final exam? Only if I locked you in a room and all that you did was take my course and nothing else that whole semester, then I could show for sure that all you did was eat, drink, take my course, and then you did well in the final exam. So that can show that you did get better at that course. So the more controlled you try to make a study, the less applicable it is, because obviously that's ridiculous to think that you wouldn't learn anything else outside of my classroom, and that nothing outside of my classroom could influence your learning about the topic to do better in the final exam, right? So the more controlled, the less applicable to the real world that it is. And that goes with any kind of studies. How do these things apply, and what should you look at particularly in your data overview and your assessment of the reliability and validity of your data sets that you're given? So first, kind of a overarching one is data collection. So as you're looking at the data that you're given, ask the question, but how are these data collected? Where do they come from, right? So you can look at the source of the data, who collected the data, how they collected data, look at the sample. So how large of a sample size was the data collection? Does the sample size make sense for the population that the study is trying to do, right? So we're trying to look at the entire population of the United States and I sample 100 people. It doesn't seem like it's quite enough of a sample to make a generalization about the opinions of the entire population of 300 million people. So to look at the sample size compared to what the population is trying to be assessed or be evaluated. Second, data entry. Excuse me. So how was the data entered into the system? Was it entered in a way that could have been error? accidental or intentional error in the way the data was collected. So do we trust the sampling? Do we trust the data entry? Is the information reliable and accurate? So is there a chance that there's something happened in the instrument that produced inaccurate or unreliable results? Simple things like uh, was there a drop down to choose state, or could someone have typed in Ohio spelled out and OH capital and OH lowercase, and all those things may be reported differently in the findings, right? So is it accurate, is it reliable, or the data entry errors? And then last is instrument reliability, which we talked about a little bit already, that can we trust that the instrument is really measuring what it's intended to measure, and are the questions right? So a lot of stuff we're looking at is kind of survey data, but were the questions leading or misleading, or did everyone understand the question in the same way that helps you assess that the data was collected accurately and the data that was collected is reliable? Second, more specific on validity, is the correlation versus causation question. So what can you say about what can you conclude about your analysis? So can you conclude that there's causation or not? Be careful not to assume there is, and to focus on correlation over causation in those cases, because that's usually all you can really conclude is there's correlation between things, not necessarily causation. Second, instrument validity. You know the instrument is valid. Was the instrument used year after year? We already saw in one of the data sets we did early in the semester that they changed the way they were categorizing metropolitan areas, right? So we almost couldn't compare one metropolitan area from year 1 to year 4 or 5 because they changed the way they categorized and coded metropolitan areas, right? So that kind of affects the validity of the instrument in a way. At least it affects the validity of what you can do, what you can conclude from the instrument. So be really careful with looking at the instrument, looking how it changed over the times maybe that they used that instrument to collect data, and how much has changed with the instrument, did the questions change, and to make sure that the instrument today is saying the same thing the instrument said last time the instrument was used. And the last is what can you conclude? So be careful what you conclude. You have to bring your expertise and information into it as well, but be careful that you are concluding what is really concludable from the data. And so we'll talk a lot about that as you give your presentations and conclude things, and we'll assess whether or not you over concluded things or under concluded things, or if you talk about correlation versus causation and things like that in your explanation. And last is bias and honesty. So think about these three things. So do the data collectors have any bias or um, reason to be dishonest in how they're collecting the data, right? So depending on who's collecting the data, who ordered the study, who funded the study, you could have lots of different bias in that data collection piece, right? So consider that, even if it's a governmental agency, what what bias might that agency have had in collecting this data, right? So let's look at unemployment data. What kind of bias could be in those who collected it? If they're trying to show that unemployment's decreased or increased, how do they frame that? How do they define unemployment, right? To either meet their needs or to meet the needs of their constituents or their boss, whoever their boss may be. So be open to that. Be open to questioning the motives of any data that you see, and questioning the motives of the person who designed the instrument, questioning the motives of the way the instrument was delivered and the way it was way the data is collected. So even the simple thing like how do they sample people to get the population? Did they email that out, a survey out, and that would roll out anybody doesn't use email? Do they use cell phones to acquire information from people, and that rules everyone that don't have cell phones, right? So what kind of bias or just poor survey design or poor design did the data collectors maybe have whenever they designed the instrument, designed the survey, designed the test? Now, participants. So thinking about what bias the participants might have in answering the survey and how it was conducted. So if we were looking at a survey of students' perception and experience with courses, what bias might students have if you found out that your instructors got your results of your test? So to be honest, if you knew that I got the results of your surveys before I did final grades, for example, so that doesn't happen. But if I did, would that change your honesty in the assessment? What if you asked questions about people's behavior using drugs or alcohol and they're underage? Would they be honest with that? What kind of bias might that dishonesty bring into the instrument? Okay, so and then last is your bias. So is the person analyzing the data, what kind of bias do you bring to the table? So there's unintentional bias, there's intentional bias that you might bring into it as well, that you have an agenda that you want to propagate. So be open to evaluating and critically evaluating your bias that you might bring into the analysis as well, and admitting that and working through that and taking that into account whenever you are analyzing the data. So focus on those three things, and I could even see everybody having a mention of these three things in your presentation where you're talking about the data and um, the validity and the reliability of the data. So data collection, data validity, and just the data bias and the honesty of the, the survey or the tool or the people involved in it. Okay, sources here that I encourage you to go and read. They're short white papers basically on this topic of reliability and validity. First one is some good definitions. The second one goes a little more in depth on it. And I'll post these as well to the Blackboard site for you to read. And you should read through these two sources that I used to create this presentation here. So I hope this answers some questions you might have had about reliability and validity, and especially in terms of this course and how you should use these two terms and concepts to create your presentations and do your analysis in this course.